Afternoon. Good afternoon. Hope everyone's doing pretty good. Thank you for stopping by. Going to build and have a little fun today since I have a day off and decided to do something a little different instead of my normal coding. We're going to code, but we're going to use vanilla HTML, CSS, and JavaScript. And with that, we're going to do a little game coding. So this should be fun. We're going to learn about game development together. Um, so I don't have very much experience with game development. I've done some things in the past, nothing of real relevance, but did have some fun doing some things previously. So this is going to be somewhat of a new experience for me, and I hope you can gain something out of it from a entertainment and learning perspective. But my ultimate goal is to build up to something a little more meaningful that I could actually play and have others play with me and maybe play from time to time on a stream and just have some fun with it and go with from there. But first things first, before we attempt to conquer the world, let's learn the basics. So that's what I intend to do today. I need one more thing I need to set up and then we're gonna get started. One second. All right, let's get going. So, best place to learn anything that you're not familiar with is the documentation. So, I am currently in the MDN docs and I'm going to try this layout. I'm not sure if it'll work for me or not, but I think I'll change that up a little bit. Let's do this. And let's move this to, that's me here, this one. There. And then let's reduce this size a little bit. We can get the full picture. There we go. And get this. All right, I think that's it. One more thing. All right. See if we can have a game built before this stream ends. I'm going to use the documentation to give us a guide on how to build it. I'll probably just build it straight from the docs initially, and then we can bring something to life after that. But this will be suffice for right now. So the first step out of 10 of the game dev canvas tutorial, and this is on the MDN developer documentation. Under this chapter is to create the canvas and to draw on it. So the first step out of 10 of game dev canvas tutorial, you can find the source code, which we're not going to worry about it, but it's good to know that it is there if we need it. Before we can start writing the game's functionality, we need to create a basic structure to render the game inside. This can be done using HTML, the canvas element. So you'll start with so I like to take notes. Notes.js. There. Start with canvas. Using your favorite text editor, create a new HTML document, save it, index to HTML in a sensible location, and add the following code. So we have our code editor of choice, which is VS Code, and we have a file named index.html, and it looks like it has styling within the HTML document, so we can do that to keep it simple as well. Best practice is to build this within its own style sheet, because this can become fairly complicated or fairly busy, if you will. And then we'll add the canvas element. I'll give it an ID of my canvas. Width will be 480. Height is 320. Let's take a look at this. Okay, that is the canvas there. There. Okay, so we see the canvas with the height and the width based upon the settings that we have built in. We have a char set, define title, and some basic CSS in the header. The body contains the canvas and script elements. The script we know will hold the JavaScript elements. We will render the game inside the first one and write the JavaScript code that controls it in the second one. The canvas element has an ID of my canvas to allow us to easily grab a reference to it, and it's 400 pixels wide and 320 pixels high. All JavaScript code we will write in this tutorial will go between the script tags. So no separate style sheet, since it is just learning. It is a best practice, but we'll keep it as designed. Canvas basics. To actually be able to render the graphics in the canvas element, first we have to grab the reference it in JavaScript. Add the following below the script tag. So inside of it, we're just creating a const named canvas and grabbing that element's ID and then storing that const in a variable named CTX, which is grabbing the canvas and using the get context method. So let's do that now. Neat. Here we're storing a reference to the canvas element to the canvas variable, then creating this a CTX variable to store the 2D rendering of the context. The actual tool will be used to paint in the canvas. To see an example of this, to see an example piece of code that prints a red square on the canvas, add this below your previous line of JavaScript, then load the HTML in the browser and try it out. So this would be copying. Let's see what this looks like. Let's refresh it. There we go. And we see the red square on screen. And that is these methods. That's helping that generate. Cool. All instructions are between the begin path and close path methods we are defining using the ret. The first two values specify the coordinates of the top. So you begin with begin path. That is the indicator that you are drawing, and then close the path. Okay. The first two values specify the coordinates of the top left corner of the rectangle of the canvas, while the second two specify the width and height of the rectangle, and that are these values. So this, we could modify the size of the rectangle with this. So I'm gonna make sure we capture that in notes as well. In our case, the rectangle is painted 20 pixels from the left. These are setting the placements of the screen, and 40 pixels from the top side, and 50 pixels wide and 50 pixels high. So this is the size. These are the positionings. And it takes two. I wonder if it takes any more parameters, but it takes at least two parameters. 4 parameters, excuse me. That are those, and this is begin path. So if we want to do another one, we could say we can move this to 40, this to 70, and let's change this to blue. Save it, check it out. And we see that's the positioning of it. So we have the blue square on a slightly different position on the axis. And let's just change the size of it. Let's make it 80. I'm making the square bigger, and if we want to make it a rectangle, we can make it something like that. Or we could go 180 and make it more of a traditional rectangle. But that's basically how that works. Begin path. Use begin to draw elements and elements and position. First two params are position, second, third and fourth. Third and fourth are the size. And then the other two, then you'll go with the fill style and fill and close path. The fill style properties store a color that will be used by the fill method to paint the square. In this case, red. We're not limiting the rectangles. Here's a piece of code for printing out a green circle. Try adding to the bottom of your JavaScript, saving and refreshing. So that was something that we just did. So we can test that out as well. All right, let's try this. So this is CTX dot begin path, and then we'll go CTX dot close path. So CTX dot, and these are the different methods. So this one is arc, and then we see the arc takes a number, a radius. So the first will be on the X. The second will be the Y. This is starting the triangle, the number, the end angle, and the positioning of it, whether you want it clockwise or not. So the parameters for this, we would say on the X-axis, we can place the position at 180. On the Y, we'll place it on 160 as it has listed. The radius of this, which is a size, would be 20. The angle, we'll keep it at 0. And then it is using a calculation. I'll just copy this for the additional parameters. And then the fill style, CTX.fill style, will make ours orange. CTX.fill. Save this and go back. And we see now we see the circle on screen. Awesome. All right, so that was that's pretty straightforward. Just kind of talking about the canvas element and some of the options that you have built in within it. So let's keep going. All right. See, we're using begin path methods. Between them, the most important part of the code is the arc method. It takes 6 parameters. Yep. The most important part of the code is the arc method. Yep, that's what we just pointed out. Takes 6 parameters, an X and Y, the radius of the arc, the start angle and end angle, which angle to start and finish drawing the circle and the radius, direction of the drawing, false for clockwise, the default, or true for anti, or I guess counterclockwise. The last parameter is optional. The fill style property looks different than before. This is because, just as with CSS, color can be specified as a hexadecimal value, a color keyword, the RGB function, or any of the other available color methods. So that's cool. It gives a little bit of flexibility on how you want to color the items, just in case you have some unique style and you're not limited. So that's good. Instead of using fill and filling the shapes with colors, we can use stroke to only color the outer stroke. Try adding this to your code in JavaScript too. Let's see what this looks like. CTX begin path, rack, stroke. And now let's check it out on screen. All right, so that is this rectangle with the stroke method being used, which is the outer portion of the rectangle is colored. Hey, what's going on, my friend? How you doing? How's it going, my brother? Welcome. I appreciate you stopping by. What's going on in your world today? All right, so the code above prints a blue stroke empty rectangle. Yep, thanks to the alpha channel and the RGB function. The blue color is semi-transparent. Compare your code. Here's the full source code to the first lesson. Run it live. I don't think we need to run that. But this is basically what it looks like. And our positioning is a little different because I just want to tweak it. But that was basically how you will get items on screen. So in the next lesson, we'll continue the second chapter and work out how to maybe move an item. Yep, we're going to add a ball and how to move it. This is the second step of 10 of the Game Dev Canvas tutorial. You can find the source code. Okay, so that's just the same message as before. You already know how to draw a ball from, you already know how to draw a ball from working through the previous article. So now let's make a move. Technically, we'll be painting the ball on the screen, clearing it, and then painting it again in a slightly different position each frame to make the impression of movement, just like how movement works with movies. Okay, so it's basically capturing it in incremental steps based upon whatever we decide to display movement. Cool. Drawing a loop to keep constantly updating the canvas drawing on each frame. We need to define a drawing function that will run over and over again, this with a different set of variable values each time to change positions, etc. You can run a function over and over again using JavaScript timing function. Later on in the tutorial, we'll see how the request animation frame helps with drawing, but we'll start with the set interval and at first to create some logic, some looping logic. Delete all the JavaScript from your current. Delete all the JavaScript you currently have inside of your HTML file except for the first two lines and add the following below them. Okay, so it looks like we are going to create a function that will run continuously based upon the numbers that we enter in for the set interval function. All right. So I can remove this. I don't want to remove it. I will comment it out. Get a function and draw. And then we'll use the set interval, pass in the name of the function of draw, and set the milliseconds to 10. Thanks to the infinite nature of set interval, the draw function will be called every 10 milliseconds forever or until we stop it. Now let's draw the ball. Add the following code, add the following inside your draw function. So it's basically using the exact same methods to draw the ball that we did earlier. So let's do, so we'll call this function CTX. Well, excuse me, we'll start with CTX and we're going to use begin path. And then we'll go CTX dot. Actually, you know what? I'm just going to copy this. Now let's check this out. And we see the ball on screen. Perfect. Try to update your code. The ball should be repainted on every frame. Let me see that. Okay, I guess that's what that means. I guess there is a slight stutter with it. Okay. You won't notice the ball being repainted constantly at the moment as it's not moving. Let's change that. First, instead of a hard-coded position at 50-50, we will define a starting position at the bottom center of the canvas in variables called X and Y, and then use those to define the position the circle is drawn at. So these are the position. Right? Let me make sure I'm not tripping. Yeah. The first two numbers are the position. So what it's saying is that we're going to replace these two numbers with variables. Okay, so let's try it. Let's do let because it may change. X equal canvas dot width. Let y equal canvas dot height. GH10 divided. No, this one is minus 10. And then replace these with X and Y. Let's check it out. So we see this is the position based upon the updated value for the position inside of that arc function. That is this position. If we change this to 4, we see the position changes. 6, go back to 2. If we make this minus 2, it should go to the right. Nope. Yep. And back in the middle. Okay. That's basically how that works. All right. So we just did. Now comes the important part. We want to add a small value to X and Y after every frame has been drawn to make it appear that the ball is moving. Let's define those small values as dx and dy and set their values to 2 and minus 2 respectively. Add the following add the following below your X and Y variable definitions. So that is let dx equal 2, let dy equal minus 2. The last thing to do is to update X and Y with our dx and dy variable on every frame. So the ball will be painted in new position on every update. Add the following 2 lines indicated below to draw to your draw function. So here's the additions, and basically it's just incrementing these positions by 2. So that is x plus equal dx, y plus equals dy. Let's check this out. So we see it's basically just drawing onto the screen continuously. Save your code again. That's how it works. Yep, that's what we have. Clearing the canvas before each frame. The ball is leaving a trail because it's painted a new circle on every frame without removing the previous one. Don't worry because there's a method to clear canvas. Don't worry because there's a method to clear canvas. The ball is leaving a trail because we're painting a new circle on every frame without removing the previous one. Don't worry because there's a method to clear canvas content, which is clear rect. This method takes 4 parameters: the X and Y coordinates of the top left corner of the rectangle and the X and Y coordinates of the bottom right of a rectangle. The whole area covered by this rectangle will be cleared of any content previously painted here. And the following highlighted new line to the draw function. So what did it add? So it changed those coordinates to 0, 0 for clear, and it kept the arc the same. So what this is doing is basically just clearing that rectangle every time this function gets called. So let's copy this in, add this into our draw function. Save it and let's check it out. And now it gives the illusion that it's moving because it is moving, it is clearing that path every time you call the draw function. Cool. Okay. Save your code and try again. And this time you'll see the ball move without a trail. Save your code and try again. And this time you'll see the ball move without a trail. Every 10 milliseconds, the canvas is cleared. The boost circle, our ball will be drawn or given a position, and the X and Y values will be updated for the next frame. Cleaning up our code. We'll be adding more and more commands to the draw function in the next few articles. So it's good to keep it as minimum and clean as possible. So let's start by moving the draw ball into a separate function. Replace the existing draw function with the following two functions. So it looks like we get ready to modularize the code and get prepared to scale. All right. All right, so let's try this out. So now we're at the point where we will be adding more and more components to the draw function in the next few articles. So it's good to keep it as minimum and clean as possible. Let's start by moving the draw ball function to a separate function. Replace the existing draw function with the following two functions. So we're getting ready to modularize our code just a squig. We want two separate functions. So we'll go function draw ball. Begin path. Let's make this gray. Not sure if that'll work or not. And then we can remove this because it is no longer needed. And let's replace it with the draw ball function. Everything else remains the same. Let's save this and check it out. So now we see we have a ball moving on screen. Perfect. You can check the finished code for this article. You can check the finished code for this article in the live demo and play with it to understand better how it works. So now it is asking to create a button named Start Game, some basic styling for the canvas, and then inside of it is setting the dimensions and the location for the ball, drawing the ball, calling the draw function, creating a start game function, and then passing in this run button inside of the button element by creating a run button ID, and then we created that console. What should happen is we'll click start game and it should create the function to run this code. So let's update our code accordingly. All right. So let's add HTML first. Make sure this took. So we see the button there. I'll give it a little bit of padding. Just gonna let's go with 12 pixels. Now we can go with about 4. Let's go padding left. Let's go with 4 pixels. Padding right. Yeah, that should work. And text. Is it text or font? That's okay. It's okay for right now. This should be suffice. So when we click this button, I want to call a function. Yo, what's going on, my brother? How you doing, my friend? Sorry I missed you, man. My apologies. I didn't have probably should put the chat on the screen. But how's it going, my friend? I appreciate you stopping by. All right. So that covers that. So we have that. Put this in a function. So we're going to put this in a function as well. So we can call it once we start the game. create a const name run game and set it equal to document.getElement by ID, and we're getting the run game, right? Run game. Let's just copy it to be sure. Yeah, it should be good, but be sure. Okay. And then we'll go run game dot add event listener to listen for a click. And we're going to call this function once we click it. And then we want the button to be disabled at that point so that it can't be pressed again. So that is basically the function. And what should happen? We should get the exact same experience as this. Yeah, that's what we should get. So let's just make sure. Yep. Probably should add a stop button here, but this certainly gets the job done. Oh, let me get this charger. 1 second. All right, there we go. All right, so next up, what is next? We've drawn our ball. Next steps, we've drawn our ball and gotten it to move, but it keeps disappearing off the edge of the canvas. In this third chapter, we'll explore how to make it bounce off the walls. In this third step out of 10, the Game Dev Canvas tutorial, you'll find the source code. Yep. It's nice to see our ball moving, but it quickly disappears from the screen, limiting the fun we can have with it. To overcome that, we will implement some collision detection, which will be explained later in more detail, to make the ball bounce off the four edges of the canvas. So in the article, we're going to cover simple collision detection, go through our code, and talk through next steps. So let's start with collision detection. To detect the collision, we would check whether the ball is touching, colliding with the wall, and if so, we would change the direction of its movement accordingly. To enable the calculations, let's define a variable called ball radius that will hold the radius of the drone circle and be used for calculations. Add this to your source code. We're just creating a const named ball radius and setting it to 10. Now update the line that draws the ball inside of the draw ball function to this. So inside of the arc, instead of defining the position by these two numbers, we're going to replace it with the ball radius const. So let's remove that. Ball radius. Hit save. Let's see what it does. Okay, didn't see anything on my side. Here it does take 4 parameters. Sorry, let's try it now. No. Still not doing anything for us. Okay. There are 4 walls to bounce the ball off of. Let's focus on the top one first. We need to check on every frame whether the ball is touching the top of the canvas. If yes, we'll reverse the ball movement so it will start to move in the opposite direction and stay within the visible boundaries. Remembering that the coordinate system starts from top left, we can come up with something like this. Just saying if y plus dy, if y plus dy is greater than 0, dy is equal to negative dy. And what this is saying is if the y value of the ball position is lower than 0, change the direction of the movement on the y-axis by setting it equal to itself reverse. If the ball was moving upwards with a speed of 2 pixels per frame, now it will be moving up with the speed of negative 2 pixels, which actually equals to moving down at a speed of 2 pixels per frame. The code above would deal with the ball bouncing off the top edge. So now let's think about the bottom edge. If y plus dy is greater than the canvas height, dy is equal to negative dy. Basically what it's saying is that if the y position is greater than the height of the canvas, remember that we count the y values from the top left. So the top edge starts at 0 and the bottom edge is at 320 pixels, the height of the canvas. Then bounce it off of the bottom edge by reversing the y-axis movement. So it basically just talks about we can merge those two statements into one. Bouncing the ball off of the top left. We have the bottom left and the bottom right. Now we need to focus on Calculate the position. We have the top and bottom edge covered. So let me do this because I would like to do this. So now I want to test this out. All right, so I see the ball again, so we're good there. Now let's add the collision detection. So if the Y value of the ball position is lower than 0, change the direction of the movement on the Y axis by setting it equal to itself reverse. If the ball was moving upwards with the speed of 2 pixels per frame, now it will be moving up with the speed of -2 pixels, which actually equals to moving down at a speed of 2 pixels per frame. The code above would deal with the ball bouncing off the top of the edge. So now let's think about the bottom. So this is your top and bottom, this is your left and right, and this is all of it. All right, so let's do this. And then now for the ball bounce, or to draw the ball, excuse me, we want to add the collision detection. And for the X, it's saying X plus DX if it's greater than the canvas dot width. I'll go minus the ball radius. Or if X plus DX is greater than the ball radius, if either one of those things are true, then say dy is equal to negative dy. No, this is dx, excuse me. Dx is equal to negative dx. All right. So now let's care for the y. So let's say if y plus dy is greater than the canvas height minus the ball radius, or y plus dy is less than is greater than canvas dot height minus the ball radius, or y plus dy is less than the ball radius, we want to set dy is equal to negative dy. And that's just updating the status. So with that, we should have our collision detection in place so that the ball will touch the edge and then bounce back down. Let's see what this looks like. There we go. Perfect. We now got to the stage where our ball is both moving and staying on the game board. In the fourth chapter, we'll look at implementing a controllable paddle. This is the fourth step out of 10 of the game development canvas tutorial. You can see the source code there. I get tricked every time. The ball is bouncing off the walls freely and you can watch it indefinitely, but currently there's no interactivity. It's not a game if you cannot control it. So let's add some user interaction, a controllable paddle. So in this one, we'll define a paddle to hit the ball, allow the user to control the paddle, compare your code. All right. Defining a paddle to hit the ball. So we need a paddle to hit the ball. Let's define a few variables for that. Add the following variables near the top of your code besides your other variables. So this is building the paddle's height and width, and it is a const because it doesn't need to change. So let's add that. Const paddle height is equal to 10. Const paddle width is equal to 75. Let paddle x equal canvas dot width minus the paddle width divided by 2. So this is to set the size of the paddle. Here we're defining the height and the width of the paddle and its starting point on the x-axis for use in calculations further on down the code. Let's create a function that will draw the paddle on the screen and add the following just below the draw ball function. So this should be easy. Should be pretty familiar with this, but this is going to draw the paddle. That's what we did before. So draw paddle would be function. Actually, let's go this. Let's name it draw paddle. And it will do ctx dot begin path and then ctx dot close path. And for to draw the shape, ctx dot rect. We'll pass in the paddle on the x, the canvas dot height minus the paddle height, paddle width, paddle height. And then the fill style is ctx dot fill style is equal to, we'll make it orange, and then we'll go ctx dot fill. Actually, I need to call this function somewhere inside of the Okay. But I should be able to just do draw paddle. Actually, let's keep it clean. Let's do draw paddle inside of this. It won't do anything, but it should at least draw it on screen. Yeah, there it is. Because I know it's not doing anything, but it at least I knew it should at least draw it on screen. All right, so cool. We'll keep going. All right, so that was the draw it. Now this is to give it some control. We can draw the paddle wherever we want, but it should respond to the user's action. It's time to implement some keyboard controls. We will need the following. 2 variables for storing information on whether the left and right control buttons are pressed. 2 event listeners for key down, key up events. We want to run some code to handle the paddle movement when the buttons are pressed. 2 functions handling the key down and key up events, the code that will run when the buttons are pressed. The ability to move the paddle left and right. So we'll add these variables next. Let me see something. Hey, how's it going, my friend? How you doing? I appreciate you stopping by. Hope you're having a wonderful day. Let's pause this, test this out. Fresh. Let's see something. That looks good. That's good. 10 paddle height, width, left, right. Okay. Yeah, we're good. I want to make sure I didn't miss anything. It's looking a little odd. Oh, just a simple HTML, CSS, JS paddle game to teach the fundamentals of game dev, and gonna practice a little bit the next few days and see if we can build something a little more complex, but just something to learn how the functionality works, and from there add a little creativity and have some fun with it. What about yourself? What you got going on today? How's your day going? Let's see something here. This thing is my apologies. Man, had a pretty good day yesterday. My Little guy had his first football game. Oh, hanging out and you working in yourself. Okay. Awesome. That's pretty cool. What type of work do you do? Alright. Yeah, all of that looks good. I just want to make sure that the size of the paddle was correct, but it looks good. So maybe I'm just tripping. We can draw the paddle wherever we want, but it should respond to the user's action. It is time to implement some keyboard controls. We will need the following two variables for storing the information on whether the left or right control button is pressed. Two event listeners for key down and key up events. We want to run some code to handle the paddle movement when the buttons are pressed. Two functions handling the key down and key up events when the code events the code that will be run when the buttons are pressed. Okay. The ability to move the paddle left and right. So we got paddle left, paddle right. And then we're adding the event listener for key down. All right. When the key down event is fired on any of the keys on your keyboard, when they are pressed, the key down handler function will execute the same position as true for the second. So this is basically how it works. Running this function. Okay. That's pretty straightforward. When we press a key down, this information is stored in a variable. The relevant variable in each case is set to true. When the key is released, the variable is set back to false. Okay. Both functions take an event as a parameter represented by the e variable. From that, you get the useful information. The key holds the information about the key. I can read between the lines. Well, I'm hoping this provides some value to your day. All right, let me add brief for the movements. That is your event listeners. We've now set up the variables for storing the info about the press keys, event listeners, and relevant functions. Now we'll get into the code to use all of the things we just set up and move the paddle on screen. Inside the draw function, we will check if the left or right cursor keys are pressed. When each frame is rendered, our code might look like this. So when we press it, it moves 7. And that is to control both positions, the left cursor, and that's for the right. So that's the key handler. So this appears to so you have your event listeners there. I think I clearly have too much code in here, but it's okay. And you have your event listeners there to handle your up and down there. Draw your ball, draw your paddle, and then the draw on screen. Change my scripts. All right. That looks a little off. Well, let's do this. Let me see what this says. So that covers that. So now I think the next step, yep, the collision piece works. Cool. All right. All right, so now I think the next step in this is to the only trouble now is that you can just continue hitting the ball with the paddle and there is no winning or losing implemented. This all will change in the 5th chapter Game Over when we start to add an in-game state to our game. The fifth step of the game, it's fun to watch the ball bouncing off the walls and to be able to move the paddle around, but other than that, the game does nothing. Yep. Really good for the game. Lose. Game over. Let the paddle hit the ball. Prepare your code. Let's try to implement game over into our game. Here's a piece of code from the 3rd lesson where we made the ball bounce off the walls. Instead of allowing the ball to bounce off the walls, allow 3 balls, left, right, top, and right. Let me see something. Give me 1 second. All right. Okay, so the next thing we are going to implement is the logic to end the game if the ball hits the bottom. Here's the piece of code from the third lesson where we made the ball bounce off the walls. Yep, if it equals the width minus the ball radius, which is the size of the ball, or if x plus dx is greater than the ball rate or less than the ball radius, excuse me. Instead of allowing the ball to bounce off all 4 walls, let's only allow 3. Hitting the bottom wall will end the game. We'll edit the second, blah, blah, blah. Yep. First, add a declaration for the interval variable at the top level. Then replace where you initially called set interval with interval is equal to set and interval draw 10. So basically just creating the const for that. So right here, well, interval is equal to there. Then replace the second if statement with the following. So this is some kind of collision interaction between ball and panel, so it bounce on the wall. I don't know why. This should be it. So let me try this. Let's see what it does. So it does alert game over. Perfect. But what happens? Oh, I can't move it. I need to update that. So this is just adding in a little bit of additional code. Just leave that like that for now. something. Okay. Well, that wasn't a lot of success with that, but it's okay. We'll try something else with it. Okay. Mm. Let me see something. I missed something somewhere. I'm not just gonna add the code in, but I do want to see what it kept that I missed. I think I see already. Mm. That should get it done. Yeah, that looks good. That looks good. Right here, I think I goofed it. Let's go back to it. No, there you go. So I removed the listener for the arrow right and the arrow left. And game over. But it didn't give an alert. But you know what? That's fine. It doesn't necessarily have to give an alert. I'm not worried about it that much. As long as the functionality works, that's really what matters the most. You should have alerted. There it is right there.